Hello folks, I'm working on a new app and I think you're going to love it. The app is called Hacktivate. It's right here on this virtual iPad and it's a cybersecurity capture the flag challenge game where users have to crack codes, decode files, analyze hex, break hashes and uncover hidden messages, all using real-world computer science skills. You'll learn a lot while you're playing. So it's going to be awesome for schools who teach computing science using iPad and Mac, but also curious minds of all ages, hobbyists, developers, and even parents playing along with their kids. Now, the main reason I'm making this video today is because the app has a number of very interesting, fun SwiftUI effects. I want to give you some insight on how they're built behind the scenes. If you're not a coder, you're welcome to hit fast forward because I'll show more of the actual app itself later in the video. First, for coders, the app's built almost entirely with Swift and SwiftUI. But I'm also bringing in Apple's new foundation models framework. I'm using Accelerate, I'm using CoreML, I'm using Vision, and so much more. This is an app that really shines on Apple's platforms. Now, there are a couple of very small bits of UI kit, the things SwiftUI can't do yet, but it's only around maybe 1% of the code. Okay, I'll run the app now. And the first thing you'll see is we have this world map that draws itself on the screen. And this effect is inspired by a game I loved when I was a kid called Syndicate, where they do something very similar. Now, I'm going to turn on for you here slow motion animations up here in the debug menu so you can see what's happening behind the scenes, right? And I'll kill the app and then launch it again. Kill it now, as you can see in slow motion, it's going very slowly. So let's kill Hacktivate and then launch it again so you can see exactly what's happening behind the scenes. So now, let's run it again. And you should see, hopefully, the map draw itself very, very slowly. You can see it's happening in 3 regions. We have the Americas being drawn, Asia, Africa, and Europe being drawn, and also islands, Greenland, Australia, and the sort of Malay archipelago down here, all being drawn at the same time. And once the line draw effect finishes, the regions fade in behind them. And this whole effect is built in 3 steps. First, I've literally built SwiftUI shapes for every region on my map. So USA, Canada, Central America, North Latin America, whatever, are all individual Swift files, one for each region, a region that draws a shape. You can see them in this big old regions folder here. Badoom, right? Lots of these things. Second, as well as those shapes, I also have the world map drawn as 3 shapes. So down here, world 1, 2, and 3, and that represents one of each of the 3 drawing components, Americas, islands, and similar. And third, when it comes to drawing, I animate the trim of the 3 world shapes from 0 to 1, which makes the shapes draw themselves. And when the animation finishes, I bring in the individual country region shapes behind them, so regions appear behind the lines. Now, if you look carefully, you'll see there's also a sort of green crossed grid thing behind it. Again, I'll kill it and relaunch. You can see it, because that's also going to draw itself behind the scenes. So let's do it again. You can watch the animation again in slow motion. Let's do it again, and you should see that green grid, hopefully, draw itself. Again, it's not very bright color, it's quite a dark color. There's the world drawing, and here comes the grid now, very, very slowly drawing in like that, all the lines, and then the horizontal ones come in like that now. Boom. Obviously, it plays back much, much faster at full speed, but I think it adds to the effect, even though it's quite subtle. Now, there are 2 really subtle things here that I think actually add to the experience. First, I don't know if you can see it or not, but there's a very subtle drop shadow drawn behind the regions. Like, there's a shadow all along here on the edge of the map like that, and including Greenland here and Africa and Australia and so forth. They all have their own shadows, and they're drawn as a group rather than having a shadow on every region. I don't want Canada to overshadow the US or the US to overshadow Mexico, for example. And this is done in my world map view code here. And it takes just 1 line of code. There's quite a lot of code in this file. Sorry, it's quite big. Down here, we get to this. Boom. That's all it takes. Compositing group, right? We make everything in the map one compositing group. So the whole unified map gets this shadow rather than individual regions. Second, if you look really closely, you might notice there's actually a subtle gradient in the colors being shown here, from a brighter green up here down to a darker green down here in the southern hemisphere. And again, it's not, massively noticeable. I think it adds to the effect. And the way this is done is so simple, it feels like cheating. SwiftUI is doing so much of the work for me here. Now, one option I tried out was to draw the map as one solid shape and use that drawing as a mask for a linear gradient. And that's not the option I went with. In fact, my option's even simpler. I draw every region, Canada, USA, Central America, in the full space of the view. So Canada looks this big. It's actually the full width and full height of the screen, and then draw this one little space here. And then I let SwiftUI calculate the appropriate gradient just for the part that's filled. And understand what I mean? Let's look at the code for just one of the country shapes, okay? I'll pick out, let's do Japan. So it's literally just a bunch of code saying move here, the exact positions for where Japan should be. But look at the range of the values. So it's giving you the rect width and height here, okay? 0.89, 0.9, 0.90, 0.89, 89, 89, It goes from like 0.87 here, maybe 0.88, up to 0.89, 1.9, right? There's a tiny range of width of the screen. That's because the shape's given the full screen to draw in. We only actually want a small part of it. That's the part we actually render to. And then I overlap 24 of these full screen shapes, with each one occupying just a tiny part of its space. So when I apply the gradient to the whole space, it's going to be calculated across the whole screen. It'll say, okay, Canada, you start up here in the top left corner, go all the way down to the bottom right corner, here's your huge gradient. But only the part you see, the actual Canadian landmass area, is filled. And so when it's combined with all the other shapes in the same coordinate space, it creates this lovely, sort of deliciously smooth gradient. And you're probably thinking this sounds horrifically slow. I am astonished how fast SwiftUI does it. It's instant. There is no performance hit at all. So impressive stuff. But there's more. Because the other thing my approach unlocks is I can now tap on countries as individual shapes and get really pixel perfect tap detection, even with complex regions that have difficult shapes, which is, all of them, right? As you can see here, Canada has all these islands at the top here that have to be included in the Canadian tap area. They're all done for me by their Canadian shape. So let's try it now. Let's go ahead and tap a country. Again, there's a slow animation that's turned on, so you can see how the effect works. So I'll press on the USA here, and you should see this line appears, and then this happens. In slow motion, the window draws itself with information about the USA as a region. It'll slide in saying, who do we have? We have the Shadow Eagles here, right? And they rose from military networks and corporate espionage wars, yada, 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 yada. Stuff appears, right? So you're going to see a bunch of things all at the same time here. You'll see the region sort of glows up brightly as being selected. There's light coming out from there pointing towards a window. And this window here has all the challenges you've got to complete in that region to continue to earn points and go to the next region, right? Now, from a SwiftUI perspective, the really interesting part here is this window. And again, there are several interesting effects here. And again, I should say, by the way, this is just regular SwiftUI components. This is just a text view. This is a regular list down here. There's nothing fancy here. There's no metal code here at all, in fact. So let's break it down. And to do that, I want to deselect the USA and select a different window so it'll draw it up again. Let's go to the other side by choosing, let's do, here, Middle East, right? First, you can see it's drawing itself, but notice how the laser line has another line behind it. This one here. It creates a sort of like a triangle shape of it drawing itself as it's tracing the window shape out. And what's happening is it creates a sort of display lag feeling as I sweep around. And what's happening is I'm drawing the line of the window being swept with a laser line, and I fill in the space between the line's current position and its position 5 movements ago. So I have a lag where it was and where it is and sort of fill the middle of the triangle. So creating this sort of laser display lag style thing here. Second, the view's contents come in, you can see in slow motion, with a simple blur replace transition. I think it's really effective. And then the text animates in. Now, because we have slow animations turned on, you can see they're going to flash white as they appear, and they kind of fade to green after they flash in white. This is done using SwiftUI's text renderer protocol. You can see it like it's being typed live on the screen. Sort of starts white and fades its way down to green as it's being written all the way across here like that. I have a whole video on SwiftUI's text renderer stuff. The TLDR is, let's control exactly how lines, runs, and individual glyphs are being drawn. And that's what I'm using here. I calculate how far through the typed text I am and fade each letter the appropriate amount. It's actually a modified version of the effect I taught in my book Pro SwiftUI. When played back at full speed, it looks great. Again, this challenge listing below here is just a regular SwiftUI list, just carefully themed to fit with my styling. And I think perhaps Apple's design evangelists may have strong words with me next time I come to Cupertino. Anyway, so far, we've just looked at the world map screen. Let's take a look at the actual app itself. To do that, I'm going to choose tutorial down here. And tutorials are the first things you see when you play the game. And it helps teach you the basis of how Hacktivate works. I'll leave the slow animations on just a minute longer, okay? So you can see there's a bunch of these things we can work our way through one by one. And each one has a tutorial followed by your turn. Like apply what you just learned somehow. So let's go ahead and try this now. We can try an example thing here. And I'm going to choose double equals, the very first tutorial here. And I'll press start challenge. And now you'll see we're going to get 3 windows drawing themselves here, because there's actually a whole windowing system happening behind the scenes here. And you'll see we have the main challenge area here, double equals. We have this hints area over here. And at the bottom is the tutorial information, because we're doing a tutorial here. So it'll teach me what to do to solve the problem. Now at this point, I'm going to turn off slow animations. I think you get the point of how it all works behind the scenes. That's fine. So I'll go to debug and put it back at full speed like that. I should say, by the way, the app fully respects reduce motion. If you don't like things moving around, boom, you just go away instantly with one switch. Anyway, we have our challenge area here, a hint area here. Again, it's a windowing system, so you can, if you want to, collapse things or hide, show them again. It's down to you. We have a top here, various tools that you'll need to solve these challenges you work your way through. We have this toolbox here, give me a range of tools to manipulate our data somehow. We have our editor here, so you can write JavaScript code. That's important later on. We have the map, which is, well, it's a map, quite frankly. But it's useful for solving challenges involving locations, coordinates, and more. And we have the data bank here, which is a whole range of techniques and topics being taught along the way. And that's dark. That should be green, really. It's only early days yet. Anyway, in this case, we're running through the very first tutorial. And you can see it's telling me, hey, welcome to Hacktivate, capture the flag. This first challenge has some meaningless text, it says, but it's hiding something. Press send to toolbox now so we can investigate more closely. So you press send to toolbox, and it's going to guide you through what to do here. So it's now saying, okay, we're looking for markers here. Try using press from Morse code. And so on the left here are things we can do to change the way our data is manipulated. And it's saying, go ahead and find from Morse code. Just look for it in the sorting or just filter at the top here. Just type Morse. I've got hardware keyboard on, I think. Yeah, Morse. There we go. So from Morse code, like that. And obviously it hasn't worked because it's not Morse code. And that's fine. So we can just swipe to delete that from our toolbox, like so. Goodbye. And instead it's saying, look, when you have 1 or 2 equal signs at the end of your text down here, it means often base 64. And so instead, you want to press from base 64 up here, like this, and it'll decode the base 64. And now it's saying, okay, what do we have in here as well? We have this ping at the start, PNG, which usually means it's an image. So we can actually add the operation render image, like this, to draw the PNG file for us. Boom. And you can see it's a QR code, and you can now go ahead and work with that. Now, behind the scenes, these things in the middle here are very interesting because the operation system in the middle as you make stuff is an array of live SwiftUI views, each of which have their own view model attached to them to track its data, and each of which can appear more than once. You may have from base64, do some work, from base64 again, other work, and it's all going to be handled very, very carefully so the views can be identified uniquely, have their own data, they render quickly, and so forth. Anyway, you can see in this case we've got a QR code, and so we've got to read its contents. So we'll do QR up here, detect QR code, add that in. It'll scan it for us and pull out the answer. Good job, the flag is bricks. And that's literally the text of that QR code. You can scan it with your phone if you want to. That text is in the QR code. And so that's our flag. And the flag is a thing we want to try and capture in every challenge, which is the word bricks in this case. So we go back to our challenge tab, enter the flag here. It's bricks, press check, and boom, you got it correct. Hooray. Now, I'm going to walk you through a few more of these challenges so you can get a feel for what makes Hacktivate fun. Let's scroll down here and try elevator music. Okay, I'll press start challenge. Again, these are all tutorials trying to give you an idea of what the app does and how it works. So it's saying press play and listen to it. Does it sound strange? Let's find out. Okay. So, as you can hear, there's this music playing here with a nice waveform view going on. But it's saying listen closely because you can hear there's something weird in there, some really deep sounds. So we can send this to the toolbox and investigate more closely. And it's saying, hey, you could try hiding things in audio energy itself. We could try, visualizing to be a spectrogram. So we go ahead and add a visualize audio like this. And it'll go, there's your spectrogram. It's pretty, but not helpful. And so we don't want that one. We're going to delete that like this. And what we really want to do is add transform audio here, which lets us do things like split the channels, for example. So I'll say transform the audio, get a bunch of controls now to handle the way audio's controlled. Again, we can split the channels, reverse it, speed it up, change its volume, whatever. It's down to you. And in this case, we can hear there's some very, very deep sounds. So we can try and speed up to say twice the speed, like this. Press execute and then press play. And that did not work. That's the volume, my mistake. Let's try the playback speed. I'm a great hacker, me. Execute. Okay. So it's still very, very slow. We don't go much faster again. We go to 400% or even like 450 or so. Press execute. And now we get this. Okay. Hope you're now thinking that sounds like a voice, but it's wrong. Now, there's actually using a technique called backmasking, where a reversed voice is placed over regular music. So we want to reverse our audio like this and see how it sounds now, and we get this result.
The flag is backwards.
Boom. There's our flag. So, back to our challenge tab. Enter the flag here. Flag was backwards. Check. There we go. Let's try something else. Back to map. We have, we can do terminal velocity, okay? This challenge tutorial set gives you access to a virtual Linux terminal. And again, the tutorial down here will help you walk through various commands like, run the ls command. And it detects that and goes, okay, we could try and read this by using cat flag.txt to read files out. So we'll do cat flag.txt and then it gives you a hilarious dad joke. It's the wrong place. And so, okay, it's not in there. We'll use ls-a to read hidden files. So it's kind of teaching you just enough to work your way through the system to learn about how these Linux terminals work. So we'll do ls-a. Oh, look, there's a hidden file, .hidden.txt. Is it in there? Let's find out. Well, we'll do cat.hidden.txt. Another hilarious dad joke. But it's not in there, so maybe it's in data. So cd data, and then ls in there. And there's the flag. So we'll do cat flag.txt and get our answer. That's our flag. Now, before I type that flag in, I want to point out this is just the very first Linux terminal challenge. This thing is capable of doing so much. If I just run the help command, you'll see it has a whole bunch of built-in commands. We've got grep history, kill all, MV, ping, PS, sudo, who am I, you name, and even netstat here, okay? And this is important because some challenges require you to gain root access, identify a rogue process, and then terminate it to get rid of the flag. Now, just to be clear, this is all fake, right? You know, I've rebuilt the fundamental parts of a Linux terminal here in Swift and SwiftUI just for Hacktivate. There's no actual hacking taking place. I'm not embedding Linux on iPads, but it's been fun thinking what people might try and do. If I try and go in here and say, okay, kill all bash, if I really want to hate myself, it just kicks you out. You're out. You asked for it, and I'll teach you for screwing around. Anyway, our flag was it command line commando? There we go, command line commando. So down here, command line commando. Go like that. I'll do just two more, and I'll talk some more about the code, because there's more stuff to explore here. It's quite fun. Let's do family reunion. This is actually a your turn challenge. I'm skipping the one before it, so it's not fair for new users, but it's fine. So users will complete the one before it here to have an idea of how to use these kind of problems. You don't have that, so good luck solving it. Don't worry, I'm here for you. There's hints too. So you've learned now to hack images apparently because you did the previous tutorial. How do you figure this one out? Well, your family are planning a big get-together, but where? Now, if you know your flags, you might know this is the flag of England. So you might go, okay, this is England here. Oops, England spelled correctly. There we go. And it's wrong. It's far sneakier than that. It's too easy. So we want to move this thing to our toolbox. Now, in this case, the image is doing something really sneaky. There are actually two shades of red in there, but they're almost identical. So we basically can't spot them with our naked eye. But your toolbox can. If you scroll down, big list of stuff down here, and find the operation randomize colors, that thing, when it's run, will assign each unique color in the image a new randomized replacement color. So they'll stand out more easily. Press execute now, and there it is. I can randomize it again, make it easy for you to see on the screen. Boom, there we go. So you can see that, wow, double equals signs. That looks to me like base 64. Now you can, if you want to, change your toolbox from image to text and type that in by hand, or if you are slightly smarter, there's actually a option up here called detect text. And this uses Apple's Vision framework to read text out from an image. And then we can attach to that thing a from base 64 to decode base 64. Boom, like that. Press execute. It'll think for a second, hopefully. The answer is Belfast. That was in the base 64. So that text was in base 64, then put into the red colors to try and find. And that's our answer. So let's go ahead and add it in. I'll do Belfast here. Belfast. Boom, done. Okay, let's do just one more, okay? One more. This one is condition red, okay? This challenge shows a whole other side of Hacktivate. Let's try it out now. As you can see, it's showing me this nice virtual web browser in the app with a big button I can press to get the flag. Except, of course, that won't work. Okay, that'd be too easy, right? Down here, it's telling me, look, before we're done here, what we're going to do is look at the page source code so we can poke around inside there. So I'll press this thing here to open that window up. And you get a subset of the developer tools you're used to seeing in Safari, right? I can see all the HTML behind this small page. There is also a console tab, a request tab for headers and similar, and a storage tab for cookies. Now the tutorial is telling me what you want to do is look through the code and see what's happening. And you'll see button on click equals show flag if allowed. Okay. Then look for that. Here it is, show flag if allowed. If user allowed, show flag. Sounds great. And below, func user allowed, alert, no thank you basically, and then return false. So the JavaScript code's written to say, you're never going to get the flag out of this. But we can have access to the page thanks to this console tab here. We can switch that now, saying activate console tab here, boom. And we can run our own JavaScript code in that page to get the flag. So rather than having a simple alert here, we'll just run show flag directly. So I'll say show flag, like so, boom. Flag is you beat me. All right. I think you get the point. I want to show you just one more SwiftUI thing. But first, I want to give you just a quick overview of who I think will want this app. As you can see, Hacktivate is designed to be a fast-paced, challenge-based cybersecurity game that teaches real-world skills through hands-on problem solving. And I've tried really hard to give it a sort of Hollywood hacker cool meets actual computing science kind of vibe, right? You crack actual codes, decode actual files, analyze hex, break hashes and similar, and all get those hidden flags while building serious technical ability. This is all real stuff. And so I think schools are going to love it because it's all teaching real things. There are tons of logic problems, tons of coding problems, cipher problems, and more, and they all teach real things like binary and JavaScript and hashing and encryption and DNS and regular expressions and so much more. It's just packed. There are 240 challenges in the app, all written by me and graded across various difficulty levels. Some of them are huge. I just cannot wait to show them to you all. For example, if I close this and say, let's go to the US and see the American challenges, there's a bunch of these here, and truth table, right? Truth table here, a simple challenge, okay? All you gotta do is change these logic gates so the lights at the top light up the lights at the bottom. That's it. You press test solution, it'll go, okay, you got one so far, these two, and lights that one up. Makes sense. This is a NAND gate, so not and, we could do or, for example, and that will light up this one down here. This is on and currently, we'd want probably XOR for that one, light that one up. And now these two are on, that one's on. So you've got to try and work your way through logic gates. Again, real computing science stuff here. Or we could go and try out, let's see, visions of a complex cipher. To a simple cipher challenge. Now I skipped over the cipher challenges in the tutorials, that's fine, sorry. But in those tutorials you learn that you can move encoded text like this one into your toolbox. Like this. And there's a special operation down here called identify cipher. Which is, for Daisy, here it is, boom. This thing. And this uses Apple's Core ML framework to analyze a text to figure out what it is. And it's saying in this case it's a Visionaire cipher. So if we remove identify cipher, zap it, we can instead add a Visionaire decode operation down here and have it go at guessing the key. Right now, there's actually this frequency analysis option down here. It uses Swift charts behind the scenes to show you how often text letters appear in English and how often they appear in your text. So you can use frequency analysis to crack the key. Or if you're a bit lazier like me, there's this brute force input text button here. And you do that, it gives you this lovely animation where it analyzes it and flicks through and tries to find the code. In this case, it's X, Y, Z. So I put the key in here, X, Y, Z, and boom, that's our answer. The flag is fuzzy wuzzy. Now, what's actually happening here is quite fun. Obviously, this is an M4 iPad Pro, whatever, anything vaguely modern is running on Apple Silicon. It can figure out the key to the cipher in a millisecond or less. But that'd be dull, right? So what I'm actually doing here is just for fun. This, when you press this button, okay, when you see analyzing cipher at the beginning, that's where the key is actually being picked out. I've hard coded it to take at least 1 second. So you'll see the text analyzing cipher, right? The whole spinning wheels thing, where it's going, oh, is it an X, an A, or whatever, that thing there, it's completely fake. The app already knows the key by that point. It knows it instantly, okay? It's just there because it's pretty much what people expect to see from a Hollywood hacker-style UI. Things going, wow, whiz, wow, amazing. They want to feel like they earned it somehow. It makes the whole process feel more rewarding. Now, this is actually just plain old SwiftUI text once again. I'm using the numeric transition here, numeric text transition, to make the letters move around, like a slot machines are spinning around. But I repeatedly trigger the transition faster than it can complete. So it creates the constantly rolling effect. The only thing that really took a modicum of thinking was making the text letters lock in one at a time, X, then Y, then Z. And also making sure I don't choose the same letter twice in a row. It looked like that wheel got stalled for a moment. Anyway, I think you've seen enough for now. That's Hacktivate. It was hugely inspired by some games I loved when I was younger. I mentioned Syndicate already. There are little hints of Command and Conquer in there. There are little hints of uplink in there, and more. These first tutorials down here, these ones are designed to introduce you to the basics of using the app, how it works. But as you visit each new region after the first one, you'll see there are more tutorials in there. So I go to Canada here, I'll say, okay, here's a tutorial to learn out something new here, so you can build and learn with Canada. The game keeps expanding with new types of challenges, teaching you what you need to know at each step as you progress. It's just huge, and it's so much fun. There's so little out there right now for this space on Apple platforms, despite very large interest in cybersecurity. I think Hacktivate will fill that gap. It's engaging, it's practical, I think it'll work great in classrooms. For home users, I'm thinking to make the tutorial section, all these here is what, however many is 16 or so, 12 or so perhaps, free to try out, so you can really feel how the app works. With the rest of the regions you can see right now, all these ones here, being available as a one-time in-app purchase. No subscriptions. For schools, I'll be supporting Apple School Manager. It'll be a paid download with no in-app purchase at all. Again, there are 240 challenges to try out here, all building on real-world computer skills. My plan is to have a final release ready sometime in October. I want to spend some time getting as polished as I possibly can, making the experience as smooth as I can, both on Mac and iPad, and if possible, get it running on iPhone too. And that's not going to be easy. There's a lot of UI in here, but I'm going to do my best because I think folks will really appreciate having the option of starting a game on their laptop, switching to their phone for a while if they get bored at the office, and then carrying on with the iPad in the evening when they're relaxing. So that's it. That's my new project. It's been so much fun to work on, and I'm really looking forward to sharing it with you all soon. I've already sent test flight links out to a handful of people I trust, and I might open up more places in a month or two. If it's something you'd like to try it yourself, let me know in a reply, and I'll see what I can do. Take care, folks.